I didn't share your. Okay, but somebody email me that the people who are cheating are not here. Yes, but some of you send it to them. And if they are not here and they are cheating, they deserve the zero anyway, don't they?
Yeah, fair enough.
They do.
Don't
If
let
you
them
cheat,
know.
you deserve the zero. What?
Don't let them know if they're not here.
Don't tell them.
Yeah.
That's fine. But guess what? If one of you who are here are sending answers to somebody who is here or not here, you are running the risk of receiving the same zero. You're the one who's doing the work and having everything fine, and then you're the one who is getting a zero still. I hate to do that. By the way, after all this time together, do you think I know who is working fine, who used to get an A in my class, and who used to get an F in my class? Do you think I don't know that? You think I don't know what you can do and what you cannot do? I know everything. I'm not that stupid. Come on. I know who did this paper and who's cheating of that person and who's copying from that person. But the idea is, if you do that, you deserve the same zero. You did the work, you used to get an A, now you're gonna get an F. Now you're gonna get a complete zero. And if I put a 0, 1 0, and 100%, you're gonna average 50. So if you know that you are doing this, if you know that you send it to a friend, go beg that friend of yours to change it, because if they don't change it, both of you are getting a zero if I discover it. As simple as that. I'm giving you this chance only on number 13 to go and change it. Even though it's going to be late, I don't care if it's late. I just care not to see the same thing and waste my time grading 10 pages of exactly the same. Anybody have any question? Please ask. I'm okay with asking. I'm a nice guy. If you need to know anything at all, if you are here participating, all you have to do is find out what the answer is of what we're going over, write it down in your own way of writing, and send me that. Is that too hard? Am I asking too much from an AP class? Anyway. Anyway, it doesn't matter, guys. It doesn't matter who did what or what happened. I'm trying to put a blind eye on this one, just making sure that you're doing the right thing. Okay? Making sure. I'm trying to force you to practice. All right? I'm going to go over some of the problems here. First of all, do you want me to go over any of the problems that you had for homework?
For this one,
You have a question about anything at all?
yeah. For this one with the graph, like, would you have
Which
to show?
one? Which graph? This one?
Yeah. You have to show.
There's no way that they can ask you about graphs because you can't send the picture in to them.
Wait,
you can
what?
do it by hand, maybe on a piece of paper, but people who are using a computer to answer the questions might not be able to answer that one.
So they're not gonna even have this one?
There might not be there. But anyway, if you're gonna do it, I would just submit it as what do you call it? As a picture.
Well, like, you have to show every calculation, because I just said, like, plugging in, the points into dy or dx.
You don't need to see the calculation.
Okay.
They do. By the way, like, look at this. Look at this. Here's the problem, right? And the point, for example, pick a point. 1, 2. Really, I'm like, is it hard to put 1, 2 here and get an answer?
No.
Really, for an AP student? I don't think they want to see that. They want to see the tick marks. For the thing here. That's it. That's all what they want.
So when we submit this one, you want us to just draw it on a piece of paper?
You can do it on a piece of paper. You can just write the numbers, and I'm okay with the numbers.
Okay.
All right? Okay. It's not a big deal. But for the AP exam, I don't think even they can ask you to do graphs.
All right.
They said that. If you read the problems, the thing that I send you for whatever they want, I don't think they're going to be able to do that. Send you asking you for a graph. Okay. There are certain problems that I really need to go over, and tomorrow you have a quiz. Remember at 11 o'clock, right? And I'm going to be here on Zoom if you wish. And for that also, if I see the same answer, I'm giving 0 to both. If I'm sure that there is a cheating here, I'm giving 0 to both. That's from now on, that's what's going to happen. So if you do it, it's on your head. And I have every right to do that, right? If you do that with the college exam, you're going to be kicked out of the college completely. You're not going to be getting a 0. And they keep warning you, if you read the security for that AP exam, there's a page about security. Read what they're going to do to you if they discover cheating. Make sure you understand what's going on so you will not lose. Anyway, maybe it's hard to catch you, but I mean, they might have a way or two. Anyway, I'm going to go over this problem because I want to. I want to go over this one because I want to again, and this one. And most probably I'm going to send you something tomorrow that's going to resemble some of these. Okay? What the test that we're going to do tomorrow. If you have a question, okay. Did anybody email me a question and I did not answer? Did anybody email me anything and I just ignore it other than please raise my grade? Anybody ask me a question on this material and I ignored it? Please tell me now. So basically, there is no reason for the copying anybody's work. All you have to do is just ask me and I'll give you the answer. How simple is that? It's just I'm trying to make you read an explanation. Maybe while you're doing the AP exam, you would remember it and put it in and have your score raised from 3 to 4, so it would be counted by college, or 4 to 5, so be proud of what you do and will be counted by your college. That's all. I'm trying to help you. Swear to God that I have nothing in my heart except helping you and trying to raise you as a person, as a student. I cannot raise you as a person. I'm not your parents. Anyway, let's try this out. This here, again, they say let R be a region between the graph of this and the graph H, which is that. Can you tell which is which? Can you tell the top, is it the cosine or the quadratic? The bottom, is it the cosine or the quadratic?
The top is the quadratic because it's like
top is the quadratic, bottom is the cosine. That is true. How would I know that?
Use your graphing calculator.
Raise your voice, please.
Use your graphing calculator.
What if I'm not allowed?
Well, the quadratic, since there's a negative in front of it, it would be negative 2x squared. So that would be like a downward curve. Downward,
yes. And this here is not downward only. It's a downward, and then it turned upward. That's never a parabola, down then up, right? Parabolas never go concaving down and then concave up. Parabola is concaving in one way, either down all the time or up all the time. That means the bottom one cannot be the parabola, right? It can be the cosine. That's how I know. Good. Okay, find the area. What would I write for the area?
Top minus bottom.
Can you please talk? Somehow your voices are very, very...
You do top minus bottom?
Thank you. It's a top minus bottom. the top being the parabola minus the bottom being this integral. Don't forget dx, and from 0 to 2, and I'm done. Right?
Yeah.
Right. Okay. Region R is the base of a solid. For this solid, at each cross section perpendicular to the x-axis has an area of this. So what did they give me here? They didn't say the cross section is a square or semicircle like we used to do in class. They did that. They give you the area equivalent expression 1 over x plus 3. Find the volume of that solid. What we used to do to find the volume of a solid of a cross section.
You take the integral of the area equation.
That's right. We used to get the integral of the area. So actually, you don't need anything but the integral of this. That's the area. That's the integral that you need to get that volume, right? And it's again from 1 to 2.
So it's
Is that right?
X plus 3?
Yes. Okay. I'm not sure if this is a calculator or no calculator. It doesn't look like a calculator section. So
you do the integral from 0 to 2 of that?
Yeah, which is ln.
Okay.
And put the 2 in, you get ln of 5. Put the 0 in, you get ln of 3. Right? So the answer is ln of 5 over 3. I did it without even pencil or paper. How simple is that? It's easy, right? By the way, it's an open book. Did I tell you that when I talked about the instructions?
Yeah.
It's an open book. That means if you have any notes with you, it works. If you have a paper with all the integrals and all the series that you might need is there. So they're not going to ask you anyway. If they're not going to ask you to use one of the one that you know. Because if they do, you already have it written, you can just copy it. Anyway, part C, right? Do not do an integral expression that gives the volume of the solid when R rotated a integral.
Isn't it?
Again, it's from 0 to 2, right? 0 to 2. Oops.
Wait, isn't it pi times the integral?
Oh my God. What?
Isn't it pi times the integral?
Okay. It's a pi times the integral. You're right.
Okay.
I'm wrong. See, you got me so angry. I don't know what I'm doing. Oh my God. Okay, here. I'm going to type it here. So it'll be right under the graph. What is it? R squared. What's the R squared? Where's the line? The line is y equals 6. It's above that graph, correct?
Yeah. So the bottom one is
So the bottom one is the capital R. So what would I write in the first parentheses squared?
So it'd be
That's R squared.
g of x minus 6 squared.
Nope.
No, wouldn't it be 6 minus?
Right. It would be top minus bottom, sir.
Oh. But it's squared, so it doesn't really matter, right?
It does matter to me.
The subtraction before.
I used to deduct points when we were in
'Cause you're-
school.
You're subtracting, not doing.
It's no. It just, you should not find a negative answer which is wrong, and then you say, oh, because I'm squaring is fine. Please don't do that. Okay?
Fair enough.
What's the other one? The lowercase r. The lowercase r would be 6 minus
Each of.
h. That's the closer one, right?
Mhm.
And then the whole thing has to be between bracket, and outside the bracket you have to have dx. If you forget the dx, they might make it wrong. I saw them doing this. If you forget that if you put the wrong limits, that's 1 point. If you write this correctly, 1 point. If you put a dx, 1 point. So, or even if they don't say dx 1 point, if they say that this is correctly 1 point, if you don't put the dx, this is written wrong. even though you typed everything correctly. So make sure that you put that dx in, and never forget it when you do an integral. It has nothing to do with your work. It just have a lot to do with scientifically correct. So if you write it not scientifically correct, it just might make it wrong. Okay, so we're done with this question. It's not that hard. Now this question, let's find out what's going on with number 9. It says, consider the family of functions. F of x equal 1 over x squared minus 2x plus k. What makes it a family?
The k.
The k. Every time you put a k as a different number, you get a different graph. That's why we call it family of functions. Okay, where k is constant number. Find the value of k for k greater than 0, such that the slope of the line to the graph of f at x equals 0 equals 6. What would you do now?
You're gonna need an integral or derivative.
So you have the derivative and you make it equal 6 at x equal 0.
And then
Okay.
find k.
That's what you do. You
Wait,
get the derivative.
Why are we
you
finding the integral if it's asking for this? If it's asking
No, the derivative. The derivative.
They say the slope of a tangent line equals 6. That means you need the derivative at 0. At x
the
equal
derivative.
0. And
I see.
you make that answer derivative equals 6.
Okay.
You solve it. Okay, so now here's the expression. How can I get a derivative of it? I can take the whole denominator, and make it like so. And then take that denominator and make it raised to negative 1. And then I'm getting the derivative that way. So the answer is negative 1, right? Times the expression raised to negative 2, subtracting 1 from the exponent, times the derivative of the inside, which happened to be
2x.
2x minus
2.
2,
Oh yeah.
right? Okay, I can rewrite it in a nice way now by taking that negative exponent and put it in the denominator. It's not working for me. Okay, cross it, leave the negative here, and divide, put that there, and equal, and erase that negative that was extra. So this out, and change that exponent, of course, to positive. I put the negative exponent back in the denominator, and I made it positive. Is that okay? Okay. Now, not equal. I'm going to take that and find the f of prime of 0. So I'm replacing each x with 0. I'm replacing x with 0. Right? And after doing so, I'm making that equal to 6. And now I find k. Right?
Yeah.
So what do we have now? We have a positive 2 because a negative outside. Would that negative make it a positive 2?
Be a
Yeah.
yeah.
2 over k squared.
Over k squared. So 6k squared equal to 2, k squared equal a third.
Plus or minus 1 over root 3, but you have to have the positive because k has to be
Exactly. It says here positive only greater than 0. That means k. Now k is negative. What an idiot. K is positive 1 over root 3. You don't need to fix it. You don't need to make it radical 3 over 3. Everybody knows that, so it's fine. This is the answer for part A. Any question? Good?
Mhm.
Next, for k equal to -8, find the value of that integral. Okay, so I'm going to, instead of f of x, I'm copying that. That's what I'm getting integral of, correct? And put that for f of x. And they say k equal -8, so I'm erasing the k and putting -8 instead, and that's what they want to get integral of. Right? Right.
Mhm.
How would I get integral of this fraction?
Write it and then do the same thing we did before.
What do you mean?
Oh no, never mind.
Okay, main rule, so.
Partial fraction?
What we did before was a derivative. You want to do a derivative for the integral?
No, because
Partial fraction.
we can't do ln because the top isn't on the right. We can't.
Correct.
Partial fraction
The top
decomposition.
is not the derivative of the denominator, so it's not an ln. What should I do? What should I do? How about
Partial
5?
fraction.
Partial fraction.
Partial fraction, correct. The other alternative is to take this and make it equal to a over something plus b over something else. Now, something and something else is the factors of these. What are the factors of these? X minus,
4 and then
what
x.
did I
plus
do?
2.
What did I do? Whoa.
So it'd be x minus 4 and x plus 2.
Yes, sir. X minus 4. And I forgot the parentheses. And x plus 2. And then I'm copying those and put them in here. Of course, one only. And then the other one here, right? That's it. Then we add them, right?
Yeah.
We add them. So the same denominator. And on top is a times one of them. That's the one. A should be times the plus 2. And then plus b times the other one. 1 second. B. That's it. Now let's try number. Let x be
-2.
-2. If you put a -2, you get -6.
So -6b equals 1.
You're going to get -6b equal 1. And that means b equal -1 over 6. Yes? Now put a 4. 4 will get rid of the b, and 4 will be 6a equal 1, which means a equal
1/6.
a equal 1 over 6. Correct. So now this integral will equal to same integral, but instead of the same integral, I'm putting that in. Like that. And this is 1 over 6. And that would be -1 over 6. Right? So I'm making the negative in the middle, and I'm done. This 1/6 is annoying me like hell. So what should I do with it?
Just take them outside.
Take them outside, because I'm allowed to take any constant as a common factor then outside. And this makes this very simple 1, and that's very simple 1. Okay? And this, by the way, is one of the easiest problems that we did in class, if you understand what we're doing. Right? Okay.
So it'd be
So-
1/6 ln of absolute value of x minus 4 over absolute value of x plus 2. right?
Say what?
Wouldn't the answer be 1/6 ln of absolute value of x minus
ln of absolute value of what?
x minus 4,
minus 4, and then the same
and then over
that, and
Yeah.
x plus 2 on the other one.
yeah. But I was saying can't write it
And if you want to combine them, that will be a good idea to combine them as ln of x minus 4 over x plus 2.
Yeah.
Okay, great, good job. So this is done also.
and then you have to plug in
Next question. For k equal to 1, find the value of integral from 0 to 2 f of x dx, or show that it diverges. So we're going to do exactly the same work again, but this time k equal 1, k equal 1. So I'm copying that integral again. And the integral this time needs a little bit of tweaking. What is the tweaking? The integral is not from 0 to 1, it's from 0. Ooh, wait a minute. Was that 0 to, that has a limit. I did not do the limit on that.
yeah.
I need to do the limit on that. I apologize very, very much. That this should equal to, what happened when you put the 1 in? You get ln of 3. It's negative 3, but absolute value make it 3.
Yeah. So it'd be ln of 3 over 3.
3. And this, when you put a 1, you're going to get another 3. So it's ln of 1. Actually,
Yeah.
this it's a 0 anyway. Ln of 1 is 0. If you subtract the same thing from itself, you get 0. Minus, by the way, if it's a 0, I'm just going to delete it. But of course, you're going to write it for them and then say 0. You don't write in the answer right away. Anyway, if you put a 0, you get 4. If you put a 0, you get 2. So basically, it's ln of 4 divided by 2 is ln of 2. No? And it's negative because it's a minus what you got. So this is your end answer for that part. Any question? Okay. What's the difference here? This is 0 to 2, and the k is not a negative 8. It is
1.
1. Right?
Yeah.
Okay.
Oh, is it?
Does this give you any clue on what you expect?
Would it be like one of those series where when you take it apart, it's like plus and then minus? But then
This is the one. This is the,
telescoping. Could it be a
no,
telescope?
this is not a series at all. What series? It's an integral of an expression. What this has to do with series? No, this has to do with this. If the denominator happened to be a 0 in the middle of this or the end of this, that means it's 1 over 0, which is undefined, which means you have to do it using limits as b approach that number.
Yeah.
Okay, let's think of factoring. If I factor this, what would I get?
X plus 2, x minus 1.
What a shame.
No. X minus 1 squared. It's a difference of squares.
Go back to algebra 1, man.
I'm bad at factoring.
Okay, it's x minus 1
Yeah.
squared, right?
Yeah.
X minus 1 squared. Good. Right?
Yeah.
Now, when is this undefined? At x equal
1.
1. That means I cannot do the integral from 0 to 2 right away. What can I do? What can I do? I can take this and divide it into 2. 1 from 0 to the 1. Then from 1 to the 2. That's the number that makes it undefined. Yes? Then, to find the answer for that, you cannot just do it. You have to use limits. How we use limits? We're going to say here, limits as b approach 1. That's the number that makes it undefined. 1 of.
So it'd be from 0 to b.
Hold on a second now. Yes, it's a 0 to b because we're going to call that a b, then find the limit as b approach whatever. Yes?
Yeah.
And then this is exactly the same one again. This is the same one again, but this time the b is on the bottom and what? And this is the 2 on top. Yes? You're going to have to do each one separately now and finding a limit. Do you understand what to do for this one?
No.
To get an integral. I can take the whole parentheses, put it on top.
Oh, yeah, yeah. I mean, what do we do?
Consider the whole parentheses one variable. So I have a one variable raised to -2. Add a 1 to the exponent. You get the parentheses raised to -1. Divide by the new exponent, -1.
Yeah.
Right? And divide by the number next to the x when you finish. So, what would that equal to?
-1 over x minus 1.
1 second now. This, and instead of all that, I'm copying, pasting. That's not what I want to paste. Copy that, paste it here. I'm going to take that. 1 second now. Where's the equation? And I need a bracket, and then I need to make it from 0. Was it 0? 0 to b. And this inside should be the answer. The answer is -1 over this to the 1. That's my answer for the integral, correct?
Yeah.
Okay. What would I write for the other one? I don't need to write anything new. I'm just copying the same and make this from b to 2. Correct? Correct. So now what? Now we substitute the b and the 1 and the 0 and everything else. Let's substitute. If you put a b, what would you get? A b, right?
Oh, okay.
Minus, if you copy the same one again and put a 0 in, if you put a 0 here, what would you get?
1.
You get a +1. So minus the +1, right? Next one. If you put the 2 for x, what would that be?
+1 again.
Still up? No, it's -1. Why +1?
It's -1 over -1.
No, sir. 2 minus 1 is not -1.
Oh, yeah.
Duh. What's wrong with you? Okay, so it's 1. It's a negative. You confused the hell out of me now. -1 minus substituting the b. Yes? Yes. Now let's put the 1 in. What would that be?
So,
Undefined.
so it diverges?
It diverges, yes.
So what do you need to do for it to converge? Would the b's have to like cancel out?
No, it has to have an answer for this.
Okay.
It has to have an answer for that. Okay.
It would be like -1.
Like if this is 1, okay, I'll tell you what. If you're only getting an integral of 1 over x minus 1, and the answer would be ln, it might work, because if you put a 0 in for x, you're going to get ln of something, and that has a value. But when it's in the denominator and you put a 0 in the denominator, make the denominator 0, it's undefined.
Okay. So do
All right.
both of them have to have an answer for it to
Yes,
work?
sir. Each one have to have an answer, yes.
Okay.
Wouldn't the answer be -1 for each one, or because of the undefined, it just doesn't work anymore?
What do you mean? I should ignore the undefined?
No, but it's like undefined -1, so isn't it just -1? Like
How does
plus-
that make sense? Undefined -1. If there's a number that I don't know, -1 is -1.
No.
That means you're assuming that the undefined is 0. It's undefined.
okay.
That means we don't know it.
Also, do we always do like the limits when we don't like when there's a value that's undefined? Like, how did you know you have to separate into limits?
That's how I know.
Averages. Okay.
The question is giving me a clue. The question is giving me a clue. Even in multiple choice, when they used to give you a multiple choice, one of the multiple choices says diverge. So if anything diverge, the word diverge is there as an option, that means this, I gotta be careful that it might contain an undefined term, which means I have to do it with the limit as I just did.
Okay.
Okay?
Yeah.
Okay. Now we're going to do number 10. Can you please read the question for 10 before we try it together?
Mr. Ayad,
Yes?
so the thing we did with the like converging and diverging of series is, do you think that's going to be on the exam or no?
No. Diverging, what?
Like what
Yeah.
we did with the telescoping and all that stuff?
No, might not be the telescoping as much. Maybe there's telescoping, I cannot get into the head, but most probably they will ask you about a convergence and divergence.
Okay.
Okay? All right. This is divided by 2 factorial, which I included in one of the questions here for training purposes. Wow. Okay. I copied the polynomial that we are using, so I fill in the numbers. Yes? Okay. We are building our polynomial as Maclaurin or Taylor third degree. So I wrote up to third degree. Yes, I copied my polynomial, which open book, that means you have it in front of you while you're doing your work, no problem. You don't have to memorize it, but you have to have it in front of you so you can copy it. And if you type in your test, I would even type that on the Word document and take it and use it. Yeah? Make sense? Even the general term I would copy. So because they ask about some terms, then the general term of something. They love to ask that way. Anyway, f of 0, how much?
You'd use the graph.
You use the graph. This is the graph of f.
So
It's
3.
at 0 is 3, right?
Yeah.
Right, so I can just put 3. F prime of 0.
Use
wait
the
a minute.
tangent line.
It's the slope of the tangent line, which happened to be negative something.
-2.
Negative 2. Rise is 1, 2 over run 1. Negative 2 because I'm going down over 1. So it is negative 2. And f for double prime, now I get it from here because that's a second derivative, right? It's 3. Second derivative is 3. And then the last thing I'm doing is the third degree. Third derivative is negative 23 over 2. So that's a negative 23 over 2. And a negative, don't forget the negative, done. I got my polynomial. It's very, very easy, I hope. Part B.
Mr. Ayad,
Yes, sir.
so would you recommend like leaving it like that or
Yes.
writing it out?
No, you can simplify it. Here, I'll simplify it. 2 over 3. The 2 is 2. The 2 factorial is 2, so it's 2 over 3. The 23 over 12.
Yeah.
Okay, 12 it is. Done. Simplify. If it's too much simplifying, like the numbers are in the hundreds over hundreds, don't do it. Don't ever do it. Just leave it.
Okay.
Write the first 3 non-zero terms of the Maclaurin series for e to the x. So here your job is to write the first 3, right? Non-zero terms of the Maclaurin series for e to the x. Write the second degree Taylor polynomial for e to the x, f of x. We never did something like that before. Let's do it now. So step 1, I'm writing e to the x. You know what? I'm writing e to the x. E to the x. I'm changing the numbers, of course. I'm just using the, I'm sorry. I'm using this as a skeleton, but I'm changing the numbers. If you remember, it was 1. It was all positive terms, plus x, plus what?
X squared over 2 factorial.
X squared over 2, that means half. And then plus
Oh, x cubed over 3.
wrong, nothing. Why nothing? Because they say, what is it? First 3 non-zero term. Did I get first 3 terms?
Yeah.
They are non-zero? Yes, I'm done.
Okay.
I do not do work blindly. I do not do the work blindly. Sometimes I do, but that's a mistake to do the work blindly. Do you understand? Now, they want to build a Maclaurin series for e to the x, for this, for e to the x times f of x. That's what I want to get, right? Okay, what's happening here? E to the x, which is that, is multiplied times f of x, which is that. What happened?
Oh yeah, that happens sometimes. Just try it again.
Okay. Okay, here it is. All right, so I'm foiling this. Again, even while I'm foiling, I do not foil blindly. Look at what they ask for and try to give them exactly what they ask for. What are they asking for?
The second degree, so you can ignore
Second degree means anything that give me more than second degree, I threw it in the garbage. If I have third degree, fourth degree, any kind of degree above the second is garbage. Is that clear to everyone?
Yeah.
So I am foiling, yes, and sometimes you can divide. Divide is the horrible one, by the way. To divide long division is really tough. But anyway, we are multiplying. And do I care for this term? The answer is no. So let's write the answers. And even when I write my answers, if anything come about that is more than second degree, I'm not doing it. I'm just going to ignore it. I'm multiplying only what give me less than second degree or equal second degree. Okay, so how we FOIL? Multiply the first times everything here, right? And what do you get? You get the same. So even typing is not a big deal. This way I multiply the 1. Plus, if you take the x, multiply times everything here. X times 3 is
3x.
3x. X times negative 2x is negative 2x squared.
And that's it for x, right?
That's it, because the next term will be x times x squared, which is cubed. I don't want it. But continue. Don't stop until you finish everything. Next term is the half x squared times 3 is 3 over 2x squared, right?
Yeah.
So plus 3 over 2x squared. And then when you multiply this by the next one, you get x cubed. This one, you get x to the 4th. So I don't need them. And that's my end answer. But even that answer, I need to combine like terms. Come on, people. We passed algebra 1 and we know that. So what is that? That's a 3x plus negative 2x is a positive 1x. And this plus that is
3x squared.
3x squared minus 2x squared is
X squared.
x squared. And all that is done. And that's my answer. Big deal? Not really. Not a big deal at all. But you just have to be careful with what you're doing. Okay, C, let h be the function defined by h of x. Equal to that, use Taylor-Maclaurin found in part A to find an approximation of h of 1. Okay, so from this, I'm using this to find h of 1. H of 1 means to me that this would be a 1. This would be a 1, right? And what about that? What would I put for that? That's f of t. Where's f?
We found
This
it.
was f. Use the one in part A, they said. Part A. This is what you got for f, right? But they want it to be what? In terms of t. It's the same function, but not x. It is t. So I'm putting t instead of x because they said f of t. If I leave it x, I'm getting the same answer, but technically I'm wrong, right? Let's do the integral of this. What's the integral of 3? 3t. What's the integral of 2t? 2t is 2t is 1t squared. It's a t squared, and we divide by the 2, so the 2 will cancel, right? And this would be divided by 3 because the exponent would be a 3. And the last one here would be divided by what?
4.
By 4. So that's a 4. And this would be
48.
48. Thank you. And now, don't forget, I'm putting all that between bracket and evaluate 0 to 1. And that would equal to, if you put a 1, you get a 3 minus 1 plus a half minus 23 over 48 equal to, let's combine all that. 3 minus 1 is 2. 2 plus half is 2.5 or 5 over 2. And the end here is something over 48. What is that thing that's over 48? This needs to be multiplied by 24 times 24 is 120. Is it? God, they don't know math. Whole numbers. We cannot add or subtract whole numbers. So it's 120 minus 23 is 97, and I'm keeping my finger crossed because I'm doing everything without a piece of paper. Anybody can tell me I'm wrong? Please do. I'd hate to leave an answer that's wrong. Okay? Everything is fine. Last question on this one is, it is known that Maclaurin series for H converges to H of X for all real numbers X. It is known that the individual terms of the series for H of 1 alternate in sign and decrease in absolute value to 0. What is this story about? Why are they telling me that?
That means it converges.
Thank you. If alternating and the terms go down decreasing and it goes to the absolute value to 0, it means it is conversion. That's what you're trying to say. They're trying to say if you find H of 1, it is conversion. Use the alternating series error bound to show that the approximation found in part C, that C approximation, differs from H of 1 by at most 0.45. Let's find out how we're going to get that error. First, remember we said there are 2 different errors. One is the Lagrange, which is the one with the maximum derivative, and the other one, which is the alternating. How is the alternating work? Is exactly equal the next term, right? Okay. We added here up to t to the third, right? We added up to t to the third with this kind of integral thing. I want to know what's the next term going to be. So that, by the way, that t to the third become that. I need the next term for this series, for the h. Okay. So what is the term that we have here? We added all of them, right? I didn't miss any. I added all of them in this here. So I need which one? I need the one with the x to the 4th term. That's why, if you look at the table, it's giving me here the 4th derivative, right? So the one that is missing, oops, I cannot do that. The one that's missing is A sub 4. Makes sense? Sub 4, which happened to be the fourth derivative. What's that?
54.
54 divided by 4 factorial times x to the fourth. Isn't that the term that's missing? The term that's next. So that term that's next will produce to you the error. Right? Right?
Yeah.
Okay. Did you notice that if you put E1 here, what number would you get? You get 54 divided by,
4 factorial.
which is more than what they ask. If it's more than what they ask, that means I'm making a big fat mistake. Can anybody tell me what's my mistake?
Because it's
Oh, you have to find the integral of it.
Thank
Right.
you. This here was the fourth term in the F. This is the fourth term in the F. That's not the fourth term in my H function. My fourth term in my H function should be that we added here that fourth term. Oops, again. Okay, Z, because I did that. Okay, so here's my fourth term. I'm going to add it this way. And then I have to put it in the integral here. I forgot the sign plus. And then I get the integral of that after changing it to t first. I'm changing that to t. And then what would be the integral of it here?
54 over 5 times 4 factorial times t to the 5th.
Plus this is 4 t to the what? Oh, wait. What you doing?
You divide by 5.
I'm getting a stupid, what do you call it? I'm getting a stupid derivative instead of an integral because I'm not smart. But anyway, so this here is my term that should be my error. After replacing the t with 1, right? And that now is, can anybody divide this for me, please? Is it less than or equal to 0.45?
0.45. It's 0.45.
It is 0.45. That means we are getting the correct answer. So I just need to know that it is the next term of my function h, not my function f. Because they're asking for h, I have to get the one for h.
Mr. Ayad,
Yes, sir.
Since it's 0, that just cancels out. But if it was a different number, like -1, you would have to subtract it at -1, right?
If it's no, subtracting the -1 will be the constant term, will not be that. See, when you subtract it, let's say the integral was from 1 to something, right? Yeah. This number on the bottom produce the constant at the end. Imagine that this is from 1 to x, right?
Yeah.
You're going to get the same expression, which is the polynomial, minus when you put the number here, you're going to get a number value for all this, and that would be your constant term. Doesn't mean it is the next term. It doesn't count with the next term.
Okay.
All right? The next term is actually the t.
So you only plug in 1, you wouldn't do minus the last two.
You allowed to take this, get the integral by itself on that. How's that? On that one single term.
Okay, but what I'm saying, for that one single term, would you do that one single term minus that
They're
one?
They're never going to do that to you. They're never going to do that because that would produce the wrong answer.
Okay.
All right? Okay. It's basically, instead of 0 to 1, you can make it 0 to x, get expression here, And then this term in the expression is the one that give you the error.
Oh, okay, because it's at 1.
Yes,
Got it.
yes, it's at 1. All right,
Would that be the answer to D?
that would be the answer for C. This is C or D? D, yes. That would be the
Okay.
answer. Okay, you going to finish this. You're gonna have a quiz tomorrow, and I'm sorry if I'm sound mean, but I'm telling you, you need to take off the ones that are the same today from 13. I did not look at 13 yet. When I go back and look at it,